So I wanted to get a video put together on some high level like software development concepts that I think are really important, and kind of narrow it down to like three things that I think cover most of software development in terms of being successful. So the disclaimer I want to give is that the type of software development I've been doing is what you'd call agile software development. I put that in air quotes because I think a lot of people describe that in different ways. Sometimes people get bogged down in sort of the methodologies and everything else like that, and almost like prescribing too much. But anyway, the I like the idea I want to get across is that the type of software development I've been doing is not something that we had strict formal requirements ahead of time, and it was like put your head down and start coding. I've spent about 10 years or so doing essentially like trying to design things for customers and discovering as you go what makes the most sense and iterating on it that way. That's probably the best way I can describe it. So the the three things I wanted to cover are the first one is something that is referred to as the 80-20 rule. It has a few different names, but the sort of the idea is essentially the same. And then the next two things are what I would call flexibility and testability. And I wanted to talk about the 80-20 rule first because I think the other two um, make a little bit more sense and why I think they're important and how I approach them if you understand this 80-20 rule. So, the idea with the 80-20 rule to start off is essentially that when you're going into developing something, um, you kind of need to assume or expect that you're not going to make the most perfect software. No one has ever made the perfect thing. You don't code something, it's perfect, it's done, and it's never touched again. It's this understanding that essentially requirements will be changing over time. Uh, you'll find ways to improve things over time, and that when you're focusing on, like, sorry, when you accept that, um, the idea is that if you spend all of your time trying to perfect, I can't speak, all of your time trying to perfect something, it's wasteful because you'll end up having to redo or undo a lot of things based on assumptions that just weren't going to be right. So, with that said, the idea is that um, people say this in different ways, but like you can do 20% of the work to get 80% of the value, or like you'll spend, um, 20% of the time like to get eight. Like it's this. It's the numbers don't actually they're not some magic numbers where it's like always going to be 20% and 80% type of thing, but you get diminishing returns is essentially what it means. And the best example I can give for that is maybe from my experience at least is that it's almost like polishing a user interface. And the reason I like using that example, at least from my own experience, is that a lot of the time, something like a user interface, yes, you can absolutely focus on usability and things like that. But in terms of like how perfectly buttons are placed and like the spacing around things and your color scheme, you can spend a lot of time trying to, perfect or get as close as possible to what you imagine is perfect for something like what a user interface can look like. It's almost artistic, right? There's don't get me wrong, there's a lot of like user experience things that you could measure that will improve usability, but in terms of feel and things like that, there's sometimes like an art to it. And I say that because I am not artistic at all and I am terrible at user interfaces. I have an understanding of what can make things usable, but in terms of they just never look pretty and it kind of sucks. So for me at least, I spend a lot of time trying to focus on functionality. So can we deliver software that will have the functionality that users need and get that in front of users so that they can try it? So even with that example, it's like I'm cutting down on the amount of time I might spend polishing a user interface, making it look perfect because my assumption is that it will never be perfect. So if I can start to focus on the features, I'm focusing on where most of the value will be, and sort of optimizing my investment into software development. And the cool thing about that is that when you focus on doing that and you get things in front of users, you'll find that as they're using it, they might say, you know what, this feature is great. It's great as is. So what's cool about that is that the amount of time that you should go invest to continue that feature might be, sort to continue enhancing that feature might not be much more, right? They might be totally happy with the user experience, right? You might have wanted to position some buttons differently or round things out, or but it might not matter, right? You might be able to then say, okay, let's deprioritize that and focus on something else, where we can get users to try it out. You might have users tell you that that feature is totally off the mark, right? So if you would have spent, half the time trying to make it look better, and it's not even the feature they want to use, that's a lot of waste of time, right? So the idea is that, again, just to kind of circle back on it, is that it's really focusing on like best bang for your buck type of thing. Like where can you invest time that will add value, and then try to get that in front of users so they can try it. It's not to say there's no place for making things look better. I keep using the example of a user interface and how it looks. Um, but you can kind of take this concept and apply it to many different things in software development. It might be that take a complete opposite approach of like an architecture. You want to design the most scalable, flexible architecture that is extremely performant, and you might spend 10% of the time in your development trying to just get something that's working, and then the other 90% trying to really optimize it and uh, handle all these edge cases, and then realize actually we were totally off the mark. We don't even need something like this. So you end up wasting all this time. So that's kind of, in my opinion, one of the most important things to think about in software development. Again, this might totally change if you're doing something that's say like a really complex system where you have requirements that are already specced out. I've never worked on something like this in my life. I almost want to say that I hope I don't have to. I really like being able to work with users and try to figure out, what makes sense for them. But if you do have systems where everything's already specced out for you, this might not necessarily apply. Maybe a concept like this does apply, but you have to kind of tailor it to something like that. But yeah, from my experience, when you're iterating and trying to arrive at sort of continuously improving software, kind of looking at this 80-20 rule is, I think, really important. So the next two things that I want to talk about, they, I think they make a lot more sense when you understand like this 80-20 rule. So I guess I didn't rehearse this or anything. I kind of wanted it to feel natural as I was talking about it. So if I talk about testability first, um, I'm a huge advocate of software testing. I'm not going to dive into a ton of detail in this video about how to test and all the different testing approaches and everything like that. That could be a totally different video. Deserves a lot more focus. But the idea is that, um, okay, if I give you an example of like of why testing sometimes is an afterthought, and sort of some of the struggles that I've heard from people's experiences, it might make a little bit more sense. So I think when we're talking about testability, sometimes people will they'll code up a whole bunch of stuff, and then they go, okay, like it's time to test it now, right? And it's not just time to test it in terms of having the developer or a dedicated tester or whatever the roles happen to look like. It's not about necessarily just having a person go through it and test it. Like I'm talking about coded tests and like test systems that can automatically test your software. So when it comes to testability, um, people often think about it after the fact, and then they go, oh, okay, well, to test this, I'm gonna have to go change all of, like, maybe not all of it, but a lot of the code I just wrote just in order to make it testable, right? So they might have designed something, they, as they're going through it, they're happy with how it looks, how it feels, the feature kind of does what's expected because they're using it and they're proving it, and then they go after, I need to test it in code. But then to do it, they have to refactor a lot of their code to make it testable. And then when they do that, they're breaking their code because they're essentially remaking the feature to make it testable. Um, from my experience in a professional setting, I think that there's a lot of time wasted doing this, and it's not wasted because testing isn't valuable. It's the exact opposite. Um, it's that people didn't prioritize testing and testability up front. It was an afterthought, and then you pay for it later, which kind of sucks. So um, in that example that I was giving, what ends up happening is that people, I don't want to say they spend double the time like making features to make them testable, but they spend more time um, trying to revamp code so that maybe they can write unit tests for it, or they can wire up a testing harness and, I don't know, make a mock environment that has dummy variables, so maybe they're not connecting to the internet or a real server, whatever it happens to be. But they end up having to go pipe, a bunch of test code and all this other stuff, and then it almost feels like sometimes double the work, sometimes more than double the work. But anyway, it ends up feeling like more work than it should have. And what sucks about that is, aside from just being more work, is that it often deters people from it, because if they're not used to writing testable code, what'll end up happening is they go, well, why do we do this anyway? We spend so much time trying to make this testable code, put the tests in place. Like, what value does this really have? We spend so much time doing it, um, and it deters people from doing it, right? So if they don't live and breathe sort of the benefits of having testable code and tested code, it can deter people from doing it in the first place, and then it kind of makes this vicious cycle. Um, I am speaking from experience on this. I'm not saying I'm an expert, but I've seen this happen a lot. So it's not necessarily the solution, like it's you just do this and it fixes everything. But I think what's really important in software development from my perspective is that if you're taking something like an 80/20 rule, I'm not saying when you're writing code, go test everything. I'm not saying write a coded test for every single line of code you have. I'm not saying that every single part of your system absolutely must have a unit test or a functional test on it. And what I am saying is that I think as you're writing code, you should think about how it will be tested, right? And I think that's a big difference. And the reason I like tying that back to the 80/20 rule is that um, if you're I'm gonna follow after all this, I'm gonna follow up with a sort of a more general, like, realistic example. But the, it's important to make testable code so that when you start to solidify things, you can start to make the decision. Does it make sense to put the tests in place now? And if so, do them now. And then you're not fighting this battle of like, oh well, I should put tests in, but I have to go rewrite all this code to do it. Like, you started writing testable code from the beginning because you were thinking about it, and then you literally have the luxury of saying, does it make sense to do the test now, or should I continue writing more code or doing something else and come back to the test later? um, there's totally situations where it makes sense to delay coded tests. Like I said, I'm a huge advocate of coded tests, but a good example is if you're rapidly prototyping things, um, you absolutely might not want to put any coded tests in place. And the reason why is if you're limiting your scope to say 1 day, 2 days, something within a week of rapidly prototyping something just to be able to show some functionality, you might end up throwing that away completely. And if you spent half your time, or like when you're looking at a scale that big, when you're spending a lot of time writing tests for something that's just going to get thrown away, that might be completely a waste of time. The flip side, though, is that if you wrote the testable code and you go to prototype something, and then afterwards you're like, hey, we're not going to throw this away, we want to keep it, we want to keep building on it, then you have the luxury of being like, okay, cool, this piece of this prototype we were building, we want to keep this part of it. and build on it, maybe we do want to put the tests in place on top of that. And then I keep saying the luxury, because at that point you're not, well, let's go scrap the prototype, remake it from scratch again so that we can make it testable. You were thinking about testability as you were going through, right? So I think, I guess what I'm getting at with testability is that when you make it a habit of thinking about it as you're developing, it feels less like a burden, and it's almost like you get all the benefits of being able to write coded tests when you want, when they make sense, when your team decides they make sense, um, because you thought about it up front. Again, big difference between coding all of the tests up front, doing a ton of what you might say is extra work because it's very situational. It's the difference between doing it all up front versus thinking about it and prepping yourself so that you're making good design patterns and design decisions so that you can test when it makes sense. Okay, so we talked about 80-20 rule, I talked about testability, and the third thing I want to touch on that's sort of like a general software development um, idea is I don't know what I call, like almost like flexibility, and I mean flexibility in terms of code. So the the example I want to be able to talk about is I guess it's best described as abstraction, right? So um, in my opinion, if we're talking about the 80-20 rule, you might say we're developing some software. We need a I'm making this up on the fly. We're going to need a database. Okay. And we don't exactly know what we need. We know we want it to be SQL based. I'm just, again, making this up. So we're going to pick MySQL. Cool. So if you started writing all of your code, again, keeping 80-20 in mind, if you started writing all of your code and you were very specific to all of the code you're writing in your system being MySQL specific, what might happen is that when you need to pivot, if you need to pivot, um, you've now sort of spread, like what you like you spread the tentacles of MySQL all through your code base. So when it comes time to swap out MySQL, maybe you want to go SQLite because you don't actually need a server. Maybe you want to go Postgres. Maybe you want to switch out to not even use SQL. You want to use another data layer. Um, when you have that dependency sort of spread across your code base, it makes it a lot harder to work with when you want to swap it out. So when I talk about flexibility, it's essentially abstraction. So with that example, what I would recommend is, again, like the testability example, think about this up front. If you're thinking, I need something that's going to have persistent storage, um, you might be asking questions like, can I store it locally? Does it need to be on a server? Whatever it happens to be. So you're kind of asking yourself those questions to pick the technology you want to roll with. But like I said at the very beginning of this, your decisions, you're not going to make perfect software. You have to accept it. Um, and if you can think about how to make things flexible and have abstractions, what you might do is have your system think about talking to a data storage mechanism, right? And maybe it's SQL specific. Maybe that's a good enough abstraction that you're like, we know it has to be SQL, but past that, the implementation, like, is it MySQL? Is it Postgres? Is it SQLite? Is it, you know, whatever? If you can abstract it and sort of hide the implementation, in my opinion, that can save you a ton of time. It does not save you a ton of time if it's an afterthought. If you've already gone and spread, in this example, you've already spread MySQL dependencies all through your code base, and you go, well, we want to switch to, again, we're going to switch to Postgres. So let's go through and start, putting everything behind an API that's going to be a SQL data storage thing. Like, that's going to cost you more at that point, right? And that's okay, because maybe in the future we'll save you more time from that point on, but thinking about it really late costs you a lot. If you can at least think about it up front and think about it as you're designing things, it can really afford you some cool some cool time savings and saving yourself from headaches later on. Another example, one of my favorites actually is logging. So in almost everything I've used, I do a lot of .NET programming. I've used Log4net professionally. I've used it in personal projects. Use Log4net a ton. Um, but I still always do this where when I'm making logging for my application, I will make a logger interface and sort of a logging utility that knows absolutely nothing from an API perspective about Log4net. And the reason I do that is that even though personally I'm very sold on Log4net, that might be the thing I start with. It might not make any sense to use Log4net as the system evolves or in a particular project down the road, whatever it happens to be. Um, and if you have something like Log4net or another logging library scattered through your whole code base, because logging is a very common thing to have in in software, and something that's generally very widely spread in a code base. If you have that dependency spread everywhere, and then you go, I want to switch it, the cost to doing so is generally very high. There's absolutely ways to sort of piecemeal it and start replacing logging or some other dependency incrementally. And I would highly recommend, if you're in that situation, you find incremental ways to do it for sure. But again, if you can think about sort of this, I call it flexibility, but like abstraction, if you can think about that early, I think that can save you a lot of time. So again, if you're thinking about, hey, like I want to put logging into my application, um, if you're like me and you're like Log4net's the best thing, or I think like Log4j for Java, whatever it happens to be. I don't know what the Python cool hotness is, but whatever you're working in, if there's a really popular logging framework that you're pretty set that you want to roll with, it still might make sense to go, you know what, I'm going to wrap it in an interface or a layer of abstraction that's logging specific for my application. Um, because down the road, that will afford you the flexibility to swap out the implementation if you need to. I want to give a good example on that. So in I'm trying to not use a professional one so I don't have to worry about anything that might be like IP. But in a hobby project I have, I'm making uh, an app that's on iOS and Android. And for the server side, we needed some basic logging. I've been running the server locally on my computer, so I just wanted some console logging, right? I can see everything on my machine, great. I want to see it as it's happening, so I don't have to necessarily step through with breakpoints. So, boom, print it out to the console. Awesome. And then at some point, we're like, well, the server's getting pretty stable. Like, we're going to just run it in the cloud. And I do way less debugging of it locally on my machine. But now that means that for me to go see the logging that we had, I have to somehow go connect to the instance in the cloud and go somehow see the console output. It's a nightmare, right? So something that was very simple, my logging right to the console, something that was very simple locally. Now I absolutely need a solution, like an implementation that's going to be different. But what I don't want to do, and I'm glad I thought about this, what I don't want to do is go swap out every single line of logging in the whole app to call some other library. So what I did from the start um, was I made a logger that's specific to my application. Um, so there's an interface for it that has debug, info, and error level logging. That's it. Takes a message, can take an exception. Really simple API. And then behind the scenes, I was just formatting like the console logging with the exception message, whatever, right? Timestamp. Um, and what I was able to do with almost no effort was just swap out the implementation. And I was able to, I think we're using Amazon CloudWatch. So I have cloud-based logging swapped right in. I didn't have to touch, all of the logging in the application. It was uh, such a little headache to do it, and it's a wildly different logging implementation. So because I thought about upfront a flexible way to do logging, I thought about a layer of abstraction that I wanted. I was able to make that swap later. Again, tying it all back to 80/20. I paid a very little price to go put a layer of logging in, right? That was my own API that I wanted. The implementation for it, again, really cheap to do. I just had some console logging, so I formatted some exception messages and all that. Um, but really, really lightweight. And what was great was that because I thought about the flexibility up front, the time savings later was great. So the three things that I've touched on are this 80/20 rule idea. So essentially, iterating on your software development so that you can focus on the highest value. That's the thing that's currently the highest value, right? Then testability, and I called it flexibility, but it's essentially abstraction. So those three things. What I wanted to kind of tie it back with was, um, I think, so a lot of my experience, I would say like a lot of my professional experience actually, not just with my previous employer, but actually like in co-op positions and things like that. It almost all worked out this way where I was doing a lot of what you might call rapid prototyping, like fast iterations. Um, so I kind of had, again, I'm not trying to sound like I'm an expert on this and just sharing my experience, but I kind of had this pattern down where I, I was thinking about testability and like abstraction, like flexibility, right, in my designs as I was going through stuff, because I was used to either throwing stuff away completely, right, because it happens a lot when you're prototyping stuff, or someone's happy with it and you build on it. And absolutely an even spread between those two things. I'm not saying everything I prototype worked out perfectly. Even if it was great code and really cool, like sometimes it just didn't make sense to pursue it, right? So what I found was really interesting was that I had a lot of that experience, and it almost kind of came natural to me when we were developing things again with different employers. But it was really difficult to articulate. So some other people that weren't used to rapidly prototyping things, this question of like, um, what's a good balance between like good engineering practices, right? Like how much time you're investing in your architecture, your coded tests, your testing infrastructure, like all those things that you would say are like really good engineering practices. What's the balance between that and just moving fast because like you're trying to explore with like business needs and requirements and things like that, because they kind of seem like they're at opposite ends of the spectrum, right? If you're trying to move really fast to answer questions, you're not doing a crazy complex architecture because you don't have time to do it. But what happens if you start to build on that thing and you put really crappy architecture in place from the beginning, right? So um, it's almost like you have to accept that you're going to toss it out if that's the case, and then rebuild your prototype from scratch because you've answered questions. And from my experience, it was like there actually seems to be like a, I don't want to say all the time, but like a pretty good middle ground where if you focus on these three things, like I mentioned, it seems to really hit the sweet spot. So um, if you can think about your layers of abstraction that you want to put in place, um, you might find that you happen to pick a technology choice, like you pick your MySQL database. That was the right thing, right? And your logging library that you picked might have been the wrong thing. Okay, no issue. Like you thought about your layers of abstraction, you can swap out the logging part and not remake your whole system because of it. That's cool. And then as you're building, you might say, okay, well, the database layer that we have is getting, pretty solid. We're building a lot more things on it. We don't really have tests on it. It's probably time that we harden this. Like we start to put these really good engineering practices in place. And at that point, again, it's not a matter of, oh crap, well, I guess we should go rewrite it so it can be testable. It's no, like we made it testable from the start. So we just go, it's almost like you're just going back and like just adding in the coded tests. That's what it should feel like, right? Like not that you're going back and remaking it to make it testable. It doesn't always happen perfectly like that, but I think those those three things from a super high level are the areas that I suggest people focus on. It's not really like a a nitty gritty technical thing, but I think those things are really important and work well for prototyping things. They work well for iterating on designs from things that are prototypes to I've absolutely taken prototypes like that into full on production where teams of people are working on them after many years, and you just keep iterating, right? So that's been my experience, but I think, yeah, like I said, those three things are what I would call sort of, I don't know if you call them like pillars or something, but like big focus areas at least that I think are important. And I think that's it. Um, I think I probably want to get some videos on maybe like uh, coded tests and sort of like a testing paradigms and how you might sort of tie those in. Maybe something on how you can measure like this 80/20 concept. Like, are you actually spending too much time in certain areas and things like that? So I'd like to break these things down into something a little bit more detailed for each of them. But that's it. Thank you.